Hey, Jasio here again, and today I'm going to try a really cool and crazy little experiment. This one's a little dangerous because it involves me using a stove. I've taken a couple precautions here. I don't have any tongs, which I really should be using, so I've got an oven mitt and this metal stick to keep it from burning me. I'm going to try to stay clear from this hot coil. This one is turned on, and this one over here is just a pot filled with ice cold water. And what I'm going to do here is I'm going to talk a little bit about air pressure and vacuums, and we're going to make this can implode. So first off, this is just a normal soda can. It's got a little bit of water, only about like that much, really not much. And I'm going to put it on this coil here. I'm going to heat up the water inside until it starts to boil, and when water boils, it goes from its liquid phase into its gas phase. It's going to become a vapor. So instead of water, we're going to have water vapor inside. And that water vapor is going to fill up the can, so it's going to look empty, but it's going to be filled with gas. And I'm going to suddenly pour it upside down into that cold water. And when I do that, that temperature change is going to convert all that water vapor, it's going to condense it quickly back into water, and our can is going to be pretty much empty. So the internal pressure is going to be close to zero. It's going to be a partial vacuum. And I'm going to talk a little bit about air pressure. Air pressure is sort of the weight of all the air molecules around us pushing down on us. So there's air molecules constantly pushing on us, but it's not very much, so it doesn't usually affect us too much. And whenever this can is empty and we have a vacuum inside, the air pressure on the outside, the air molecules pushing on the outside of the can, that difference between the pressure on the inside, which is almost zero, is going to be so much, it's going to crush the can. And that's going to be really cool to watch. So I'm just going to wait a little bit until this can starts to boil. So I've turned up the heat a little bit and waited, and you can already see a lot of steam starting to come out of this, and I can hear it boiling. I can hear it bubbling up in there. So that means it's just about ready. I'm going to give it another couple seconds, and then pay close attention as I quickly flip it upside down into that cold water. And now it's really steaming up. Ready? Here. So you can see here, the can has totally imploded. It looks like I just grabbed it with my hand and crushed it. Turn that off. But really, I didn't do anything. The air around it crushed it. Because there was, essentially the can was empty on the inside. And normally when we have a container, it's usually filled with air or filled with liquid. In this case, it really was empty. And that pressure difference caused this can to implode. So you can see that there. Now that everything's turned off and cooled down, this is no longer hot, I thought I'd give you a closer look at it. You can see what air pressure did to this poor little can. It's crazy to think the types of forces that are acting on us every day, all the time, that we don't even think about. There's air pressure on us right now, but it's not doing anything. But that same air pressure destroyed this can.